Alright, we did sp3 hybrid orbitals in the last video, so now we are doing sp2 hybrid atomic orbitals. So it's kind of the same thing we did last time. We're going to take our electron orbital diagram, energy level diagram I should say. We're going to have a 2s, 2p, and let's put some electrons in there. And we're just going to start with one electron in each of them. And then we're going to hybridize them. And what we're going to hybridize, just like the name implies, sp2, we're going to take the s orbital and we're going to take two of the p's. Really, really simple to figure out where those orbitals are coming from. Okay, sp2, that means 1s and 2p orbitals. So that leaves us with a p orbital, and that 2p orbital stays at the same energy level. And then we have the sp2s. Alright, and we still have our electrons. Okay, so let's look at the bonding in an sp2 hybrid, or we're going to draw the bonding picture. So we're going to do C2H4. C2H4, and what that looks like is double bond between the carbons and two hydrogens bonded to each carbon. Okay, and what we're going to see here is where that double bond comes from. That's the key to this sp2 hybrid, is we get to see how the double bond is formed. Okay, so I'm going to put in one carbon and then another carbon over here. Okay, and I'm going to draw the sp hybrids first. I'm sorry, the sp2 hybrids. And it's going to be difficult to draw because technically these are all on the same plane, but it's not the plane of the screen that they're on. They're going to be kind of poking, these ones kind of to the left and the right of the carbons are really coming out and going into your screen. So the ones poking down are kind of coming out, and the ones poking back are kind of going into the screen. And I don't like the way I drew that one. At least I can erase. I cannot erase in paper, okay, or on paper. Anyway, so there we have the sp2 orbitals, okay. I'm just going to label them just to make things clearer. So these are all sp2, sp2. Notice each carbon has 3 sp2s. Okay, so those are our sp2s. And now I'm going to add the p orbitals, because that p orbital is still there. And that is important. Okay, so those are the p orbitals. 2p and 2p. And then remember, each carbon only has one 2p orbital. The 2p has two lobes. All right, so now let's bring our hydrogens in. Okay, hydrogen, hydrogen, hydrogen. Whoops. Hydrogen and hydrogen. There we go. And now let's add their orbitals. Okay. So now, oh, and might as well, while we're here, might as well say what kind of orbital this is. 1s, 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 and 1s. Okay. That's supposed to be a hydrogen there. All right, and now let's go ahead and put some electrons in. Okay, so we have a bond here. There's some electrons in that bond. Bond here, 2 electrons, here, here, and here. All right, so now we have our most of the bonds done, not all of them. What kind of bonds are these? I'm going to go with a different pen color. Let's do rainbow pen, just for the heck of it. These are sigma bonds. Sigma bond, right there. Sigma bond, sigma bond, sigma bond. And what about this one? Sigma bond. All right. Now let's talk about the p orbitals. So we had a sigma bond before when we had in-axis or overlap along the axis. So between the carbons, for instance, we have a sigma bond. Now, I didn't really draw this exactly to scale. These p orbitals are really big and fat, but it just gets really confusing to draw all of this stuff. So what we have here is this side-by-side overlap. Okay, and what does that form? Usually what I do in classes is I say, how many bonds does that form? And everybody wants to say 2 because there's one on top and one on the bottom, right? Wrong. It's one 2p orbital, okay? It's just a 2p orbital. So that forms, it has 2 electrons and it forms a pi bond. This is a pi bond. And what is a pi bond? It is formed by side-by-side overlap of a p orbital. Okay, so we have side-by-side overlap of a p orbital. That's the pink highlighter there. That forms one pi bond. Okay, so let's just count everything. Let's count all the bonds. Make sure we have the right number of bonds in our molecule. So let's go up to this Lewis structure here. We have 1, 2, 3, 4, 5, 6 total bonds. So if we count them all, there's 1, 2, 3, 4, 5, and 6. That's 5 sigma bonds, and that is 1 pi bond. Okay, and now this is incredibly difficult to show without a model. I usually bring a model into class and I hold it and I actually show you. Okay, so just bear with me. Because of this side-by-side overlap in that pi bond, let's pick a different color here. Because of this side-by-side overlap, top and bottom, above and below that, the carbons, one thing that's really important about a pi bond is it does not allow this molecule to spin. Okay, the carbons can't rotate relative to each other. They are locked in a rigid position. If this were just a sigma bond, it can spin along that axis. But because there's a pi bond above and below, it is rigid and it cannot move. Okay, so that is really, really important. So let's see, something else that is sp2, let's sum up sp2 hybrids. sp2 hybrids. Okay, so something else that would be an sp2, really you got to have a double bond there. Whoa, hello, yikes. Someday that won't happen when I'm teaching in class again. Okay, so there's an sp2 hybrid. That carbon, that central carbon, that's an sp2 hybrid. Okay, let's see. That's pretty much anything with a double bond really is going to be an sp2 hybrid. But the main thing is, if we have 3 things, Doesn't matter if they're lone pairs or if they are atoms. Three things gives us an sp2 hybrid, and that is the basic shape, or that is to say electron geometry, which I keep repeating, of trigonal planar. All right, so that is it for sp2 hybrids.